For the lesson 3.2, Ready, Set, Go, it's all about graphing lines. And it might look really difficult because, hey, I've got two different lines that I have to graph here, but that's all it is I have a line that I'm going to graph and then another line that I'm also going to graph on that same axis, or on that same coordinate plane. So we have 2, 3, 4, 5, 6, 7. So we're going to start going by the y-intercept, and then the rate of change will tell me how I move, that slope. So I'll go up 2 over 1, and up 2 over 1, up 2 over 1, and I could keep going, but I won't. So instead, we should have something that looks a whole lot like that. And the piece that I'd like for you to have here is that you're identifying which graph is which one. So that there's my f of x, and then I need to graph my g of x. My g of x starts at positive 5 and goes with a rate of change of negative 4. So down 4 and over 1. So down 1, 2, 3, and over 1 again. And you'll see there that I have an intersection right at that coordinate point that both of them overlapped. So this is my g of x function, and my point of intersection is right where they overlap, right where they cross, and that would be at 2, negative 3. Negative 3 would be the point of intersection. For number 3, same thing. All of these, same thing. Graphing the two lines and then just seeing where they cross. So for number 3, going down 2 to start, and then down 1 over 1, down 1 over 1, down 1 over 1. And I can continue that all the way. And one thing that I like to be picky about is graphing something all the way through. Okay. Something that I didn't do for number 1 that I should probably be more particular about is adding the arrows on, because those are continuing on past the view that we have of that graph. So this will be my f of x, and then let's go ahead and set up the g of x. So my g of x is actually off the grid. Oh no. And it needs to be up 2 over 1, which also means that it can be back 2, or down 2, back 1. Down 2, back 1. Down 2, back 1. And I'm doing this just to show that, oh, there is an intersection that's happening right there. Put some arrows on there. There's my g of x. And the point of intersection will be at negative 4, positive 2. And of course, I'll do the one with the big F word, take care of the fractions. So number 5 starts, so f of x is going to start to begin at positive 4. That's not quite positive 4. That's a little bit better. And go up 2 and over 3, that vertical change and horizontal change. We can set it up like that. So there's my f of x, and then my g of x will begin at 1 and go down 1 over 3, down 1 over 3, down 3. And that line that I just drew isn't perfect, but you can see that the intersecting point is going to be right here. It'll be at -3, 2. Now, something cool that you could do with this is you could plug this back in. If I plug -3 into each of these equations, I should get +2 in return. And you would. And that's what that intersecting point means. That's where the output is going to be the same as the input in each of those functions. For number 7, we have 3 things that we're doing. So for number 7, the first part, we're trying to identify where it is increasing, decreasing, or constant. So we can say that it is increasing from here to here, from here to here, and from here to here. So what that means is, since they're closed circles, we can say that from -10 to -7, from -6 to -2, and from 7 to 12, all increasing. They are decreasing from here to here, here to here. So it'll be -13 to -10, and -2 to +5. And we're using that closed bracket because we have that filled in circle. It's including that value in our domain. And this is using that interval notation. For the second part, we need to identify if it has a maximum or minimum. We can say that it has both. It has a maximum of 8 and it has a minimum of 1. Okay, looking at the height. And the domain, using interval notation, would be a little bit funky. So it's a little bit tricky, but it's just breaking it up into pieces. Let me give myself a little bit of a clean slate here. And a new color. So the domain is going to go from here to here. It's going to stop. You can notice that there's a gap of almost 1 full unit. And then it's going to go from here to here, and then from here to here. So that domain is going to be all these numbers, and all these numbers, and all these numbers. And how we represent that is -13 to -7, -6 to +5, and +7 to 12. The range is the vertical values, okay, those y values. That one's a little bit easier because it's just figuring out we start here and we end up here, but there's a little gap there. So there's y values all through here. There's y values all through here, but nothing in the middle. So we go from 1 to 4, and then 5 to 8. A little bit tricky there. All right, for number 9, where it is increasing, you can see increasing. It is increasing from negative infinity. So this one is an open circle, or open parentheses, because negative infinity doesn't have that definite point. So we're going to keep that as an open parentheses. And then we'll go to -2. It is constant from -2 to +5. And it is decreasing from +5 to positive infinity. Okay. Now the second part is identifying it if it has a maximum or a minimum. Well, the most it can go up is to +2, so we know that this has a maximum. Then the third part is the domain and range. Domain, we're going to assume, I know it doesn't have the arrow on the end here, but we're going to assume that it's going to go off into both of these different directions. So we know that this is going from negative infinity to positive infinity. The range starts up going way, way, way down, goes all the way to negative infinity, as far as we know. So it'll go to negative infinity and all the way up to here, +2. Recursive and explicit. Those good old equations that we've spent a whole lot of time talking about already, and we're going to continue cycling back, or spiraling back and seeing what's going on. So the tricky part for these is looking at both the output and the input steps. So the inputs are jumping by 1, which is good. That helps us see what's going on a little bit easier. The output, I'm adding 6, but then adding 12, that doesn't work. So I can multiply by 2, and that does. So I know that when I am multiplying by 2, my constant ratio is 2, and my f of 1 is 6. Well, I have everything that I need, and you can go back and look at previous notes, previous examples, to see how you set up these equations. So for the explicit, just as a reminder, f of x equals this is n. F of n equals f of 1 times r to the power of n minus 1. So we would have f of n equals, my f of 1 is 6 times 2 to the power of n minus 1. Yay us. There's the explicit. For the recursive, we first define our first term in the sequence, and then define how to get every next term. Take the previous one and multiply it by 2. And that's what you have. All right, for number 13, as I had forewarned, we need to take a look at the input to make sure it's going up by the same amount. Well, it's not. Going from 4 to 5 it is. So what I'm actually going to do down below is recreate a table that makes it a little bit easier for me to see what's up. So I know that from 5 to 4, it's going down by 2. So just to continue with that, I'm going to see if I can get, and I do, the same values. So I know going up each next step, going to be adding 2. Our equation, when we know that it's arithmetic, will be f of n equals f of 1 plus your common difference times n minus 1. So our explicit equation for this problem, for number 13, would be 5 plus 2 times n minus 1. And as I've been mentioning, we need to make sure that we start simplifying these. So we would end up with f of n equals 2n plus 3. And just as a way to check to make sure, you can always go back in to your table, plug in a couple of those values, and see if it works. 5 times 2 plus 3 is 13. 1 times 2 plus 3 is 5. Just a way to help with the process. For the recursive, we need to define our first term and explain how to get the next term. We take the one right before it, and we add 2. And that's it, folks. For number 15, oh, negatives. I don't like negatives. That's fine. You're not really dealing with negatives. You're dealing with multiplication. And multiplying by 4 each next step. I know that these are all going by 1 step each. So f of n equals your f of 1, which is negative 16, times 4 to the power of n minus 1. For your recursive, define your first term in the sequence, not f of 1 necessarily, but the first term in the sequence. It's negative 4. And to get every next term, take the one right before it and multiply by 4. Hopefully this helps. Let me know if you have any questions.